So in the first task, all the LEDs which are LED 5 to 8 needs to be turned off in sequence if the switch is pushed, and when the switch is released, all the LEDs should be turned on. So we look at the main script. So at first we need to initialize the LED. So we need to initialize the LED 12 to 15 to output mode. Then we need to light out all the LEDs. So we set it clear bit for the pin GPC 12 to 15, which are the LEDs pin. Then after all the LEDs are light out, so we configure the external interrupt pin, which is GPB15, to the input pin. Then we can run this function, which is the int callback. So in this function, while the switch is 1, so when the switch is released, the switch is assigned to 1. When the switch is pushed, then the switch is assigned to be 0. So when we press the switch, so it is switch equals to 0. So all the LEDs will be turned off in sequence, which is 12, 13, 14, and 15, which have the delay in between. So when the switch is released, all the LED will turn on back. So the GPIO clear bit is used in this case. So in task 1, when the switch is pressed, the LED will turn off in sequence. When the switch is released, the LED will turn on back. So for the second task, we need to connect a switch to pin 0 of GPE. So whenever the switch is pushed, one of the RGB LEDs should be turned off in a sequence, and when the switch is released, all the RGB LEDs should be turned on. So we look at the main script. So at first we initialize the LCD, then we clear the LCD. Then we initialize all the RGB. So all the RGB pins, which are GPA pin 12 to pin 14, are set to output pin. Then this one is for the printing on the LCD screen. So we're going to print lab task demo. Then we're going to set the external 12 MHz crystal. Then we have a delay for a stable clock. So then we light out the RGB. So in this function, the 3 RGB pin is set to clear bit, which means to light out the RGB. Then we configure the external interrupt. So we're going to open the GPE pin 0 and connect it in as an input pin. Then for the GPIO enable, so for this one is the port and this one is the bit. So this one is the trigger, where we need to identify the trigger type. For this one, it will be the edge based trigger. So then this one is we need to specify the mode. Then we need to go to another one, which is to set the interrupt callback function separately. So it will be GPIO pin port AB and also GPIO CDE. So in this function, we'll get bit, use the function get bit to get the value from GPE pin 0. So and then it will be saved into this variable RGB LED. So when the switch is pressed, the RGB LED is equals to 0. So all the LEDs will be turned off in sequence. And when the switch is released, all the RGB LED will be light out.
So this is for task number 2. You need to connect an external pin to GPE0 here. So this is the switch, and the other pin you connect it to the ground. So the question asks for that whenever the switch is pushed, one of the RGB LEDs should be turned off in sequence, and when it is being released, all the RGB LEDs will light up. For the last task, where we'll be playing around with the 7 segment as well as the keypad, So as you can see here, these are all the functions. Since we're trying to display 0 to 9 with different speeds, so each of this function represents one particular speed, whether it's fast or slow, depends. So this is the main part of the code, and as you can see here, this is where you initialize. This is where you initialize the keypad input. So whatever you whatever number or input you pressed on the keypad, it will save to number. This is just to display lab task demo on the LCD screen, and this is where you print it. This is the initialization of the keypad itself, initialization of the LCD, and this is to clear up the LCD. So this is where everything starts. So while one is actually an infinite loop, so it will go continuously. It will loop continuously. So as I mentioned before, number is actually the input from your keypad, and so if your number is more than 0 and is less than or equal to 9, it will go into this part of coding. So this is the first part. So if your keypad number is 1, it will display 1. This part is actually a function. So if you go back up, you'll see it will display at what speed you are. So in this case, we are at speed 1, the fastest speed. So speed 1, so number 1, it will display speed 1, and it will activate the 7 segment where it would go from 0 to 9 for 20 times, where it loops 20 times, and it will display number 0 to 9. So this is the function that's calling to display the 7 segment. So if you go back up, you go to button 1, expand this, you will see how this actually works. So how it works is that, let's say, ignore the comments. Let's say the number is 5. It says we'll be dealing with 0 to 9. So the number is 5. The digit value will be 5 divided by 10, which is 0.5. And it will close the 7 segment and will show this the first position of the 7 segment, since we're using 2 7 segments in this case. Actually, you can just use 1 for this task, but yeah, it's the same. So this is just the delay, and for this part, it will show the 0 position number of the value. So let's say if it's 5, so you get 0.5. So the first positional 7 segment will display the number 0, because we're taking the digit number 1, the first position. And you will multiply it by 10, you'll get 5 again. So the 7 segment will then show number 5 for the 0 positional of the 7 segment. You can see later in the demonstration. Else, it will just close. When it's done, it will just show 0, 0. So this is this part. It means that at position number 1, it will show number 0. At position number 0, it will show number 0. So on the 7 segment, at the end, it will show 0, 0. That marks the end of the count. The same goes to all of the other buttons. The only difference, all this button is the same, but the only difference is actually the speed, which is, in this case, let's say this is number 1, which is the fastest speed. So it will loop for 20 times. And if it's number 2, which is a slightly more slower speed, it will loop for 70 times
number 3 for 1 or 3 times, and it increases as the number increased. So for number 9, it will be the lowest speed, so we need to make sure that the pin for the number 0 to 9 on the 7th segment will be at the slowest speed, which in this case I've set it to 410, so it will repeat 410 times, which will be slower. Yeah, so that's the whole code. So that's how you do it.
Okay, so for the last task, we will be playing around with the keypad as well as the 7 segment. So each keypad represents speed. So as 1 will be the highest speed and 9 will be the lowest speed. So if you press 1, the speed will be very fast, but if you press 9, it will go very slow.